lesson in our Unit 4 topic, using graphs, is being able to identify independent and dependent variables. How do you think you can do? Do you think you can identify independent and dependent? You have that strong connection with that science fair, so you should be feeling pretty fluent at a level 3 or 4, or 2.5 to 4, with identifying independent and dependent variables. So I want you to underline that. That's your learning target. You can identify independent and dependent variables and create or analyze graphs. And I want you to cloud out analyze. That's the doozy. Cloud it off. Yep, cloud off analyze. A lot of times when we tell kids to analyze something, they start wanting to shut down. But you are not gonna. You can do it. We need to identify some vocab words aligned with this and its relationship to math. Variables is the relationship between two quantities. Whether numerically or with words like teachers to students, age to money, bills to money, energy to time. Those are all variables. What I'm comparing. It's what you are comparing. Now with math is aligned with graphing, especially at the 8th grade level. Independent variables, the ones that are independent, go on the x-axis. The ones that are dependent go on the what?
Y.
Oh, you knew it. Go on the y-axis. Independent x, dependent y. So now we know where they go, but can we still do the learning target of identifying what's independent and dependent? I don't think we're quite there. I think some of you might be like, oh, I can pretty much tell, but are you truly at that level 3? Okay. Age and height. Notice age is independent of height for a time being, right? The older you get, the taller you get until you reach a stalemate for a while. So age is independent. That keeps changing. Your height doesn't depend on your age doesn't depend on your height. Or I'd be really young because they'd think, oh, you're short. That means you're young. I'll go with it, but that's not how it works. Okay? Age, independent, height, dependent. Bills and money. Bills is independent. Money depends on how much bills you have, right? Okay, so you don't really need anything there, and just it's kind of an overview of it, besides the definitions of the vocab words. All right, next page. Next page. This is aligned with analyzing a graph with our learning target. I can analyze a graph. How you can analyze a graph is look at them, you're matching tables and graphs. You look at these two graphs, A and B, and you identify which table is aligned with which graph. Okay, so that's doing the analyzing. You're looking, you're trying to figure it out. So, what's happening in graph A? It looks like it increases and then a sharp increase. What's happening in graph B? It's always decreasing. So that's, before I even look at the tables, I try to figure out what's the graph doing. The graph is increasing and then a sharp increase. This one, the graph is constantly decreasing. Now, using that knowledge, I can go to the tables. Ice cream in container, bowls of ice cream 8. So, if the container is full, I have no ice cream, 8. If the container is half full, 5 bowls of ice cream have been 8. If the container is empty, 10 bowls. Which graph do you think that would go with? Amanda? Say that again? And why do you think B? Yep, because it keeps decreasing. But this looks like it always goes like this, x, y. So this is the independent one. Ice cream in the container. Actually, that's flip-flopped. Let's flip-flop. Bowls of ice cream is independent. Yep. Bowls of ice cream is independent. And how much ice cream is dependent on how many bowls you have ate, right? So as this increases, as the bowls increases, ice cream's going to decrease until you're left with no ice cream left, right? Yep. Good job, Amanda. Hey, years of education and your annual salary. Now support, there's only one answer left, so you need to support. How do you know that this matches that graph? And I want you to talk to two people around you on how you can use logic to connect this table with graph A. Talk. Okay, I heard some good discussion. For those of you that were talking about how this table is connected to graph A. The biggest thing I heard was kids saying increases. Increasing is a huge vocab word that will help you match graphs. If you know if it's increasing, decreasing, not changing, that's going to be the biggie to help you match the graphs. So here I know it's increasing, and I see here a big jump, which is connected to this big jump. So, playing the matching game. All right, that's analyzing graphs, part of your learning target, analyzing graphs. Next, this is my favorite. This is creating graphs. So look again at your learning target. I can identify blah, blah, blah. We already did that. And create a graph. This is creating the graph. So box off create, underline graph. Box off create, underline graph. That's what we're doing right now. Creating. Love it. First, determine location of variables. That's the first thing you're going to do. Second, determine if it's increasing or decreasing. And third, drive. So where do the variables go? Does it increase or decrease? Drive. Watch. Songs you have as you get older. Songs you have. Which one is independent? Songs kind of, do you have a lot of songs when you're 3 years old? No. Right. Do you have a lot of songs when you're 9? Getting there a little bit. How about when you're 14? So what's dependent on the other? Age is independent. So age goes here, songs goes here. Your songs depends on your age for some people. And now we graph a rough graph. This is different. This is just representing us. So when we're 0 years old, how many songs do you have? Zero, maybe a little bit. And then do you think all of a sudden you do a sharp increase or a little increase? Little increase. And then all of a sudden you become a teenager. What happens then? Shoots up. And sometimes you just kind of stay for a little bit. Okay, you're always increasing. That's nice. That's expensive.
New songs come out like every day.
Sure is. I don't buy a new song every day. Amount you play as you get older. What do you think? Do you think as you get older you play more or less? Less. So playing depends on your age, right? So the amount you play depends on your age. Okay, so how much do you play when you're a baby, the first year? No, you don't. You sleep and cry and eat. You don't really play. So I would say you don't really play at all, and then all of a sudden you got a big increase, right? Don't you? You should be drawing what's going on. And then you're just always playing because you're like a preschooler and you're like, all I have to do is play. This is fun. What a life, right? And then all of a sudden you start school. Then what happens? Ah, man. You only play a little bit and now you're busy. And I guess playing depends on what you define as playing. Some of you, you're gaming, you're social mediaing. Those are all representations of play because it's just how you spend your leisure time. Okay. Oh, this next one's sad. Time you spend with your parents as you get older. What happens? What happens? Eli, what happens? Time on the what? So time is independent, is what you're saying. Because as time increases, as your age increases, the amount of time you spend with your parents typically decreases, right? Time. Let's keep this positive. Okay. So when we're little, guess what? All we do is spend time with our parents. And then all of a sudden it slowly starts decreasing.
School gets in the way of parent fun.
Heck yeah, it does. We gotta taxi you around and do homework. Oh, here's a fun one. Distance from the ground, Noah. Distance from the ground as you ride the power tower.
What's the power tower?
That Riot Valley Fair that either shoots you up or brings you down. Okay, hold on. This is gonna look different. Watch. This is where we have to really be able to analyze graphs knowing what's gonna really go on. So what should go on the bottom here? The two things we're talking about is time and height. So what goes on the bottom? Time will always go on the bottom. Time and age always go on the bottom because age is a part of time. And what else? Or height goes on the side. Height depends on how long you've been on the ride, right? Mm-hmm. So when you haven't been on the ride, how high up are you off the ground? Nothing. And then now it depends which power tower you're riding. I'm gonna say the one that you shoots you down. Shoots down. Okay. And 3, 2, and 1. Okay, so you start nowhere and then you slowly start getting higher than you should be in the whole entire world. You shouldn't be up this high. This is not normal. Okay? And then you stay there and they're like, when do you think we're going to drop you? When do you think we're going to drop you? And then what happens? Fast or slow? Fast down, up a little bit, down, up, down, up, down, up, down. Right? Do you agree? No. Do you think you're all going to have this, 8th graders, look at me. Do you think you're all going to have the same graphs today?
No. Yeah.
I'm looking for a broad idea. So you're all not going to have a graph like this. What I'm looking for, my expectation of you, is that do you know you go up? Do you know you stay? Do you know you go down and then up a little bit? I'm not looking for 1, 2, 3, 4, 7 different peaks. Here, I'm not looking for the exact same thing. I'm looking for around the right way. Do you know how to analyze the two variables? All right?